Qualitative risk analysis. This is prioritizing risks for further analysis or action by assessing their probability of occurrence and impact. Qualitative risk analysis facilitates focus on high priority risks. That is the key. You have this big list of risks. What do I do with them? Which end is up? Qualitative risk analysis helps you figure out what the ones you need to focus on first are by helping you focus on the high priority risks. Qualitative risk analysis is assessing the priorities of risks and their impact on the project objectives. Qualitative risk analysis is subjective, so attention should be paid to identifying bias and correcting for it. It's so important. We all have our own ways of perceiving things, which are resulting, and the filters are resultant from the sum total of our experiences, and that leads to bias. Now, an objective facilitator can also help. And I strongly suggest it. Have somebody objective come in and look at the project and help you facilitate the qualitative risk analysis, help you prioritize the risks. This way, there's absolutely no bias and you have an objective viewpoint. Now, qualitative risk analysis is performed throughout the project lifecycle. It's conducted at the beginning of each iteration during agile projects. Now, in qualitative risk analysis, interviews are a prominent vehicle for data gathering. As we're doing qualitative risk analysis, we look at a risk data quality assessment. Now, this is definitely susceptible to the phenomenon of garbage in, garbage out, or GI-GO, right? If you have bad data, you're going to get bad data out. And really, you have to ask the question, is the data useful for evaluating risks? Again, thinking about garbage in, garbage out. If not, you'd better get good data. Now, for quality assessment, questionnaires can be helpful. Now, collecting data about risks and fully understanding those risks tends to take longer than anticipated. As with so many things in project management, people tend to think, not a big deal, not a big deal, and it ends up really being a big deal. Now, we have risk parameters as we're discussing, and how do you assess them? Well, we need certain things to be able to assess these risk parameters. How urgent is the risk? How near is the risk for occurring? Or how dormant is it, meaning how long has it been since we captured it? Is it still valid? How manageable is the risk? If it happens, how detectable is the risk? How connected is the risk with other risks, with the project deliverables, et cetera? What is the strategic impact if a risk occurs? What is the propinquity of the risk? The propinquity is when the risk is perceived to matter by one or more stakeholders. So another way to put this is, how do the stakeholders perceive the risk? And how controllable is the risk if it occurs? So now we've prioritized the risk, and now we look at quantitative risk analysis, which is numerically analyzing the combined effect of identified individual project risks on overall project objectives. Quantitative risk analysis is a bit more sophisticated than qualitative risk analysis. The good news is it's not required for all projects. It requires specialized expertise to do quantitative risk analysis. You need to have software and time because you have to develop risk analysis models to be able to perform this analysis. Now, quantitative risk analysis is performed on risks confirmed as substantially impacting the project, having been prioritized during the previous step, qualitative risk analysis. Quantitative risk analysis tends to be conducted for large, complex, or strategically important projects. Again, I mentioned the first step to this risk analysis is qualitative risk analysis. And you'll note, having gone through that, thinking of just showing, what we're doing as far as prioritizing our efforts, well, that's great. Now we know the priorities of the risk through the qualitative risk analysis. Now we look and we ask, is quantitative risk analysis viable? It may not be possible if you don't have sufficient data to support the numeric models, or you have garbage in, garbage out. And it certainly is not required if qualitative risk analysis was sufficient. Do not, I repeat, do not think you must always do quantitative risk analysis, because it does require the time investment, the expertise, and in many cases, the prioritization that results from the qualitative risk analysis is definitely satisfactory. You don't always have to go and do quantitative risk analysis like I just mentioned. Now, the only reliable method to assess overall project risk through evaluating the aggregated effect on project outcomes of all the individual project risks is quantitative risk analysis. This is the only way to do that. And interviewing and facilitated workshops are highly applicable to help facilitate your quantitative risk analysis. With quantitative risk analysis, you engage in simulation. Now, the Monte Carlo simulation models are most often used. In this situation, computer software runs a simulation model like the Monte Carlo simulation several thousand times with varied inputs. This way you could see and play what-if scenarios and do an analysis on the various outcomes that might occur. Simulation outputs present a range of possible outcomes, usually in a histogram format. So remember your statistical analysis days through although an S-curve is often used. And here's one right here. Now there's also sensitivity analysis, and this helps determine the risks having the most potential impact. It correlates variations in project outcomes with varying elements of the quantitative risk analysis model. Tornado diagrams display calculated correlation coefficients. Remember your statistics? Correlation coefficients for each element in the quantitative risk analysis that can influence the project outcome in descending strength of correlation. It looks like a tornado. And in this one case, we're saying it might have less of a probability of occurring if it's less than 0, or a greater probability of occurring. Each of these items down this this column are various risks. Another quantitative analysis approach is decision tree analysis. This facilitates the selection of the best alternative from several possible courses of action. Each branch in the tree represents a course of action, each with different costs and risks. Endpoints represent the outcome from following a particular path and can be expressed with positive and negative values. Threats are expressed with negative values. Decision trees calculate the expected monetary value of each branch. This facilitates the evaluation and selection of the optimal path. And here's a decision tree analysis example. Each step of the way, we are assessing a decision node and we are applying the potential costs. These are the probabilities of it occurring. We have the inputs and outputs, by the way, as well. And then we have the different estimated monetary values here. And you would choose the one that has the highest value. Now, quantitative risk analysis outputs provide an assessment of the overall project risk exposure. It supports a probabilistic project analysis where quantitative risk analysis outputs are presented with a narrative interpretation. This provides a prioritized list of individual project risks. It supports an analysis of trends in qualitative risk analysis results. It supports the generation of recommended risk responses.